Hello, welcome to another session of algorithms. In this session, we'll look at selection sort. So, when we have a number set to be sorted, we have an array of integers. So, array of 6 integers that should be sorted from smallest to the largest. So, we have 6 integers as indicated here, and we have a plot as well. So let's apply the selection sort algorithm. So step 1, if you follow the steps, it is really easy about the selection sort algorithm. So start by finding the smallest entry. So you iterate through the array and you find the smallest entry. So that is index 4. You can see 0th index, 1st, 2nd, 3rd and 4th. 4th is the smallest. Next, you swap the smallest entry with the first entry. Then you swap the smallest with the first. So the 4 will come to the first entry and this will go here. So swap the smallest entry with the first entry. So once it is done, you can see the current number set is like this. So we swap the smallest entry with the first entry. Now you can see the array has two parts. The left side is sorted, which has only one element, and you have few elements in the unsorted side. So part of the array is now sorted. So sorted side, which is highlighted in blue, and the sorted number in white or ash, and the unsorted side in red. So again we apply the same rule. In the unsorted side, we find the smallest element in the unsorted side. So that is smallest element is in the index 5. So we look at the smallest element in the unsorted side. So here it's an important point that we are considering only about the unsorted side when looking for the smallest element. Next, you swap the front of the unsorted side. So you swap that number, the smallest, to the front of the unsorted side. So previously it was here. Now we are considering only about the unsorted side. You put the smallest number to the front of the unsorted side. So next we adjust the sorted side and the unsorted side. Now you can see two elements are in the correct order now in the sorted side. So sorted side has two elements which are in the correct order, and the unsorted side has few elements like that. So we apply the same rule again. The process continues. Smallest from the unsorted, swap it with the front, and the sorted size is gradually getting bigger. Previously it had only, first time we had only one element, next two elements, now it has three elements. And next the process keeps on happening. The process keeps adding one more number to the sorted side. The sorted side has the smallest number arranged from small to large. So we can stop when the unsorted side has just one number, since that number must be the largest number. So we continue the process, and when the unsorted side has only one number, that is automatically, obviously, the largest number. So the selection sort algorithm, now we can see the array is now sorted. We repeatedly selected the smallest element and moved this element to the front of the sorted side. So what we have to do is we repeatedly did the same operation. The operation is we found the smallest element of the unsorted side and we moved it to the front of the unsorted side. So that is the only operation, simple operation that we did. So if we have a summary again, we have a set of numbers. We first find the smallest entry and we move to the front. Swap the smallest with the first entry. Next we divide, saying sorted and unsorted. We look at the unsorted side. So initially the full number set is unsorted. Now you can see part of the number set is unsorted. So we are looking at only the unsorted side. We find the smallest number and we swap it with the front of the unsorted side. So here it's important point, we swap it with the front of the unsorted side. So we continue the process. So the sorted side is gradually getting bigger. The process continues. So gradually you can see the number set is sorted. If you go to the implementation of the selection sort, so first we have class selection sort and we have void sort int array. So one by one move boundary of the unsorted sub array, and here we find the minimum, and next we swap the minimum with the first element here. So this is the code to swap the element, swap the minimum element with the first element. So this is the code for the selection sort algorithm. So this is a Java implementation. Class selection sort, void sort, we have the method and we get the values and we move the boundary sub array, we find the minimum element once we find the minimum element in the unsorted array, we swap the found minimum element with the first element of the unsorted side. So it's mapping to what was discussed in the lecture. So we have the same operation in the code. So we have the print functionality to print the array. So inside the main, you have a set of numbers. Inside the public static void main, you have the set of numbers. And once sorted, so it will have the output. So let's try to run this. So we have selection sort.java. So if we run this, we can see the sorted array is printed. So we had the numbers 64, 25, 12, 22 and 11. So sorted array 11, 12, 22, 25 and 64. So now you can see the array is sorted with the selection sort. So this is the code for the selection sort algorithm. That's the end of this demonstration.